Lesson 11.4, Join and Separate Angles. Here we have a drawing of some angles. We can see the vertex is the letter B. We have angle A, B, D. That's this bigger angle. We have two smaller angles that are inside of this bigger angle. We have angle ABC, that's 40 degrees, and angle CBD, that's 20 degrees. And we can find the measure of angle ABD, the larger one, by adding the measures of the two angles, angle ABC and angle CBD. The measure of angle ABD, this larger one, is equal to the measure of angle ABC plus the measure of angle CBD. We have a 40 degree and a 20 degree angle. We add them, we get 60 degrees. And the measure of angle ABD is equal to the sum of its parts. It has two parts, two lesser angles that are within it. When we see this M with this little angle and then these capital letters, it means the measure of angle ABD. And the angle addition rule says the measure of an angle is equal to the sum of the measures of its parts. So this means we can find the measures of an angle by adding the measures of the lesser angles within it. We can measure angles with a protractor, a thing like this. We can record each measure, then find their sum. We need to find the measure of angle RST. Here's R, here's S, and here's T. So we need to find this angle measure. We know it's a very small angle, isn't it? So we know it's going to be less than a right angle. It's an acute angle. And we can line up our vertex, this red dot, with the hole in the center of the protractor. We can line it up like this, and we can line up this ray with point T on it at the 0 mark. And we can see right here that it's a 20-degree angle. See that? Now we need to find the measure of angle TSU. That would be this angle. So again, we're going to line up the center of the bottom of the protractor with this vertex S, like this, and then we're going to line up the 0 mark right here near point U, and if you look, we can see that this is 50 degrees. We know it's not a 130 because this is less than a right angle, isn't it? So we see this one's 50 degrees. So if this angle is 20 degrees and this angle is 50 degrees, we know this greater angle, RSU, must be 70 degrees. We add the two smaller angles together, it must be 70 degrees. The measure of an angle is equal to the sum of the measure of its parts. Now look at this circle. We have many angles in this circle, don't we? We've got this angle and this one and this one, and we've got this one. And we can find the measure of each angle in a circle. The first one says the measure of angle ATB. So we know T is the vertex. That's the center point of the circle. We have ATB. So we're looking for this angle measure. So we can use our protractor and line it up with the red dot in the center point and then straighten it out so that this line for A is lined up on the 0 mark. And we look, if this is 0, that's 10, 20, 30, 40, 50, 60, 70, 80, 90. That's at 100. It's open to the left, so we're using 0 on the left side of the protractor. This is a 100-degree angle. We record it, and now we need to find the measure of angle BTC. So we need to find this one, and it's opening to the right, so we can use the 0 of the protractor on the right-hand side and line it up with the center point on the T. So now we're using 0 on this side of the protractor. It's opening to the right, we use the 0 on the right. That means we need to use the inside measures, because if that's 0, then we have 10, 20, 30, 40, 50, 60, 70. And it looks like the line is in between 70 and 80. It's at 75. And we record that amount. Now we need to find the measure of angle CTD, so it's this small one right here. So we can line up that center dot on the protractor on the T, and we can make the 0 on this line segment because it opens to the right. We have our vertex T, the red dot right in the center of the protractor. We have this lined up with the 0 mark because it's opening to the right. We're using the right side. And if that's 0, then that's 10, that's 20, and it's in between 20 and 30. Look, it's at 25. So the measure of angle CTD is 25 degrees. Now we need to find this big angle, angle ATD, and we can line our protractor up like this to find the angle measure, or we could line it up like this to find the angle measure. We line the red dot with the center of the protractor. We have this side at 0. And if that's 0, we have 10 right here. So we're going to use the outside scale of the protractor, and we can see it's 160 degrees. And we learned in video 11.2 that a circle has 360 degrees. Will the sum of these angles equal 360 degrees? Well, we have 100, we have a 75 and a 25, that makes 200, because that's 100, right? We have 100, 200, 360. So yes, the sum of these angles is 360 degrees, and that's how many degrees are in a circle. So we can write an equation from the angle measures we found. We found the measure of angle ATB was 100 degrees, and the measure of angle BTC was 75 degrees. The measure of angle CTD was 25 degrees, and then the big angle, the measure of angle ATD, was 160 degrees. And we write 100 degrees plus 75 degrees plus 25 degrees plus 160 degrees. We add them all up. It is equal to 360 degrees. So yes, the sum of the angle measures is 360 degrees. We know we measured correctly because a circle is equal to 360 degrees. If we are given an angle measure and the measure of one of its parts, we can use subtraction to find the missing addend. It's telling us that the measure of angle WPY is equal to 70 degrees. So this greater angle is equal to 70 degrees. It's also telling us the measure of WPX is 40 degrees. And we know the measure of an angle is equal to the sum of the measure of its parts. So if this is 70 degrees, and we know the measure of angle WPX is 40 degrees, we can use subtraction to find the missing addend. 70 degrees minus 40 degrees is 30 degrees. That means 40 degrees plus 30 degrees is equal to 70 degrees. We know that that must be a 30-degree angle. We can use a protractor to separate an angle into two equal angles. So here we have this angle, and we need to separate it into two equal angles. So the first thing we do is measure the angle. It's opening to the right, so we're going to use 0 on the right side, and we're going to line up this vertex with the center of the protractor. We have our vertex in the center, and we have it lined up with this ray on the 0 line on the right-hand side of the protractor. So if that's 0, then we're going to use the inside scale, because then that would be 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. So we have a 90-degree angle, and we need to divide it by 2. And 90 divided by 2 is equal to 45. That means we need two 45-degree angles. We've already got it lined up on the vertex with the center of the protractor, and this is at 0. All we need to do is find with the inside scale, because if that's 0, that's 10, right? 20, 30, 40. So it'd be between 40 and 50. It would be right there, and we put a little mark. And we're going to use that mark and the straight edge side of our protractor to draw a ray. We line up the vertex and the mark we drew, and we draw along the straight edge, and we make a ray. And now we've created two equal angles that are 45 degrees each. And we can use a protractor to separate an angle into 3 equal angles. We divide the measure of the angle by 3. We line the protractor up with the center point on the vertex. It's opening to the right, so we're going to use the right side of the protractor. So this is lined up with 0. And if that's 0, we have 10, 20, 30, 40, 50, 60, 70, 80. It's a 90-degree angle again. So we've got 90 degrees. We need to divide it into 3 equal parts. So 90 divided by 3 is, if you said 30 degrees, you're correct. So we need to mark 30 degrees and 30 degrees. We put a mark at 30 degrees using the inside scale because it's opening to the right. That's the scale we use. And we need another 30, which means we're going to put a mark at 60. Now we can use our straight edge to connect the vertex to those marks. And we can draw this one from the vertex through the mark. And now we can do it to the other one. We use the straight edge from the vertex through the mark. And now our 90-degree angle is divided into a 30, a 30, and a 30-degree angle. 3 equal angles. In video 11.2, we learned that a straight angle measures 180 degrees. And we can find a missing angle measure by using what we know about straight angles. Here we have a straight angle, AND. It's making a straight line, isn't it? It's also showing us that the measure of angle ANB is 50 degrees. And the measure of angle BNC is 110 degrees. So knowing that this angle, AND, measures 180, we subtract the sum of A and B and angle B and C from that 180. We have 50 plus 110, that's 160, and 180 minus 160 is going to equal the measure of angle CND. Do you know what it equals? If you said 20 degrees, you're correct. We're going to use some higher order thinking skills for this problem. It says join an angle measuring 20 degrees to angle JKL. So here's angle JKL, and it's telling us to join an angle measuring 20 degrees. So we think it says join, not separate. So it's not telling us to separate this so that there's an angle inside. It's telling us to join it with an angle. So we need to add a 20-degree angle to one of the sides. We can add it over here, or we can add it over there. We can line up vertex K with the center of our protractor like this. It's opening to the left, so we can use 0 on the left of the protractor and line up this ray with the 0 line. So if that's 0, we're going to use the outside scale, 10, 20, 30, 40, 50, 60, 70, 80, 90. It's at 100 degrees. We need to add 20 more degrees for an angle, so we just go to 110, 120, and we put a little mark. And now we can use the straight edge to connect the vertex and our mark. We draw our ray with the straight edge. And now we can label this. We have JKL. We can make that M, couldn't we? Now we have angle LKM that measures 20 degrees. And also remember, we could have added it on this side if we wanted to. We could have lined our vertex K like this and lined up this line like this so that that was on the 0, and we could have gone from this measure, now we're using the inside measure 100 to 120, go like that, and then connect the vertex to that mark and make the 20-degree angle on that side if we wanted to. We could have put it on either side. Emma, Tala, and Sujin each ate an equal-sized slice of pizza. The measure of the angle of each slice was 36 degrees. What is the measure of the angle they ate? So, we think we need to find the sum of the angle measures of the slices they ate, and they each ate one 36-degree slice. We can use repeated addition, and we can add 36 degrees plus 36 degrees plus 36 degrees. We could even stack them to make our addition easier, couldn't we? We could also use multiplication and do 3 times 36 degrees. To add them, we have 6 plus 6 plus 6, that's 18. We regroup the 10. Then we have 3, 6, 9, and one more is 10. That's 108 degrees. We can use multiplication. We learned back in Chapter 2 in video 2.10 how to multiply with 2-digit numbers and use regrouping. We start with the ones place and do 3 times 6, which is 18. We regroup the 1, then put the 8 down. Now we do 3 times 3, which is 9, plus 1 more is 10. And we still get 108 degrees. And because we did it both ways, we know the amount is correct. The amount of degrees must be correct because we solved it using addition and multiplication and got the same answer. So we can use addition to find an angle measure because the measure of an angle is equal to the sum of the measure of its parts. If we know that's a 50-degree angle and that's a 30-degree angle, then we know this whole thing is 80 degrees. We just add its parts together. And we can use subtraction to find an angle measure by using what we know about the degrees of a right angle, straight angle, or circle. We know a right angle is 90 degrees, so if this is a missing angle measure and it told us this is 60 degrees, well, 90 degrees minus 60 degrees is equal to 30 degrees. That would have to be a 30-degree angle. And we know a straight angle is 180 degrees. If it told us this one was 130 and we didn't know what this one was, we could do 180 degrees minus 130 degrees and we would know that that's a 50-degree angle. We know circles are 360 degrees, so if we know this big space here is 330 degrees, we could subtract that from 360 and we would know that that's a 30-degree angle. We can use our prior knowledge, things that we know about angles, to help us solve angle problems. So a review for reading angle notation, that's the symbols and identifying angles. If we see an M and then a little angle and then capital letters, it means the measure of angle ABC, and that middle letter is the vertex. So it'd be the measure of angle ABC. And if we see capital letters like BA with an arrow pointing to the right over the top, that's the symbol for ray. That means ray BA. And this is ray BC. And there are 3 angles that share vertex Q in this diagram. We have angle AQB, we have angle BQC, and we have the greater angle AQC. And you're going to learn a lot more about angles in 5th grade, 6th grade, 7th grade, 8th grade, and even high school. Our next lesson, 11.5, is problem solving, and we're going to find unknown angle measures. We're going to act it out to find unknown angle measures. Have a really nice day, and I'll see you next time. Bye.